Hello and welcome to yet another video. And today we have an MSI board, an MPG B550 Gaming Plus. And I have no information to this board why it isn't working. I just know that it is defective. And yeah, so let's see what the behavior of this board will be. And let's try to put power to this. So let's see right now. And we have very little power consumption, next to nothing actually. Very interesting. They are properly connected, so that isn't the problem. Okay, let's try to put a processor in here. Oh, I can already see one thing. The socket seems to be coming off. Someone has fiddled with this socket before. Like it's lifting at that corner, but it's still kind of attached. It doesn't look like it's damaged or replaced in any other way. Let's see. Let's put a processor into here and see how this will behave. This is a 3000G. Really doesn't feel great the way it's going in. Let's see. Do we have... Yeah, we have post LEDs on the right here. Let me get a speaker and also a power button onto here. So let's see again. Now the power consumption is a little bit higher with the processor in here, which is a good sign. Let's now try to press the power button. And we do not appear to have any reaction to the power button. I'm pressing it right now and there's nothing happening. So let's see if we have voltage on our power button. So let's get a ground and let's probe the pin. And we do not appear to have any voltage. So the voltage of the battery is there, but we don't have... Oh, now we have 3.3 volts. Okay. So it was just bad probing. So you know what this means. I suspect missing components somewhere. Probably around the SIO, maybe around the CPU socket. So now let's go under the microscope and have a look at the area around the SIO. And would you have a look at this? Someone has worked on this SIO before. Very interesting. Has this been replaced? I don't think it has been replaced. Something here looks off. Like there's definitely been work on this area at the top here. Very, very interesting. I had no information about that this board has been worked on. Let's get tweezers and see if these pins are connected or not. And trying to go in between them, but they seem to be connected. Just a lot of flux in between here, as you can see. But they seem to be all soldered. So someone might have either reflowed this or put on a new chip. Oh, great scratch. Doesn't matter, it's only the masking. And testing each of these. And they seem to be all fine. So it would be really hard to find missing components here, because obviously the area has been soldered and reflowed and the pads have gone puffy back again. So if we would need to have a look at this area especially with a board view and compare the values, because it's really hard to tell now what has been happening here. especially because there's still a lot of flux left. But I cannot see any problems so far. So let's go a little bit more around the main board and have a look if we can find any more places that either have been worked on or might have damage. And so far I cannot see any damage. We were moving closer to the CPU socket, which would be the next suspect that I would have to have a closer look at. Oh wow. What is this? Holy moly. What happened here? Okay, there's just a big hole here. With this big trace being damaged and probably this small track being damaged. Wow, how does something like that happen? Okay, let's get my Dremel out. And let's clean these places up and have a look at that. So, let's get the masking off of these traces here. So, now having quite something exposed, what you want to do is to take a cotton bud, take your cleaning detergent, in my case IPA, just clean it up, just to have a better look. And we can clearly see that also the small one is also broken. So not only the big one is broken, but also the small one. So let's restore these and then have a look if the board behaves any differently. So let's put on some flux. And what we want to do first to repair these traces is to have a good amount of solder on the exposed parts that we have. And this is what you want to see. You want quite some solder on all of these pads so that they can properly hold a wire. And now for the task to find an actual wire that is small enough to fit properly in there. So let's see, is this wire too big? This wire might be fine to use here. Let's try that. So what I always do, I pre-tin the wire. So I get flux onto the wire and also put solder also on the wire already. Now begins the actual hard part, where we will need tweezers to properly position the wire and try to tack it onto here. Let's clean my tip a little bit. And the wire really wants to attach to the bigger trace. And we might have gotten it. Let's see. So what I want to do is, if I can break this wire off without it coming off, then it's actually soldered. So if you do this and it breaks at the wire like here, it is actually properly soldered onto there. So let's do the same thing with the one next to it. That should be easier because we have way bigger of a contact area. So my biggest problem right now is that on the traces on the board, there's very little solder right now. and with with this low amount of solder, it's hard to attach the wire, but I think we've gotten it. So let's see again if this can be taken off. Yep. And let's now clean it up, because cleaning that up also is a very good indication if it can survive the cleaning. It's probably properly attached here. So now with the area mostly cleaned up, it looks like we have our wires properly attached. So to the big trace right here, going to there, and the smaller trace going from there to there. And this one we didn't touch because this one was intact, as we saw earlier. And let's now try if the behavior of this board is any different, if we can power up now. So let's have a look. Our passive power consumption still looks similar to what we had before. Let's see. And still no reaction to the power button. That is sad. I suspected it might have a difference already. But not in this case. Still something wrong with the board. Okay, let's have a closer look at that area again. We want to check if my soldering was properly or not. So what I do to check my connection is I actually use the Dremel again, and in this case we have an upper pad that we can use for the middle one that goes up to there to test the connection. And what we can do is like go here and just Dremel a little bit away here, and then also for this big trace get like a little bit exposed here and then a little bit exposed here. Now we clean the area up where we have Dremeled. And now we take our multimeter in continuity mode. And what we do now is we just test continuity before and after. So for the big trace we go here and here, and we have continuity now. And we can also check if we have cross continuity, what we don't want, and we do not. And now we can take this pad right here, and this should be connected to the lower one right there. And it seems like it isn't. Yeah, we have no connection to there. So my soldering isn't proper here. We have no connection to there. Oh, we do? Do we? Let's see, are these my probes? Yeah, these were my probes. We do have proper connection. 0 ohms from there to there. So our soldering here is proper. So this isn't the problem anymore. Let's go further on the board and see if we have any further physical damage somewhere. So we've already fixed one issue. I suspect there might be more. And we will probably also have to have a look at the board view to see if there should be components here or not. Because this area has always also been worked on. Because there's like really dark residue, which is probably leftover flux from the previous one who worked on this. Like around here. Like when I work, it more looks like this, where it just looks like wet afterwards, and not like this here where it gets like this is dark. So let's continue our search. We're still around the CPU socket right now. This area also looks like it could have been worked on. Let's quickly go to the BIOS here. And the BIOS also looks like it has been flashed. So that someone probably took this chip off and tried to flash it. And that resistor right there doesn't look healthy at all. Might want to check that one as well, right in the middle. So we're moving closer to the top of the socket. Like, multiple pads here look weird. Like, if you have a look at especially these two pads, they look like there was like someone damaged these, or right here and like here. So yeah, doesn't look great. And this is our PWM controller, which also looks like there was work done here. Ridiculous. Like, is there any area where someone did not try to fix something? This is the top of the socket. And yet again, it looks like this resistor at the top here looks like it took a hit. Just like this capacitor. In this area, looks like someone has been probing here a lot. Like, I can already tell this board is going to take us for a treat. So we're currently at the area right in front of the power button. Also doesn't look like any damage here, but also doesn't look like anyone has worked here, which is good. And with that, we've mostly been around the top side of the board, but I would definitely want to take off the heat sinks and look under there as well. And what we want to do is, let's go onto the back side of the board and have a look there, because I suspect still some damage somewhere. So what I've instantly noticed are all of these capacitors on the backside have been soldered or have been attempted to be soldered. Like, someone clearly didn't get enough heat into the board when trying this. And what this indicates to me is that someone has tried to replace the socket probably, and most likely has failed to do so. And even more close to the RAM, this is what the person tried to do. So I was looking around the board quite some more, and I couldn't find any obvious damage. But what I found is just so many different places where resistors look like this, where they look like they're partially chipped, and they might have been replaced or something has been done to them, which is really hard to tell if it's okay or not, because you can't also check every single one, because you're going to be spending hours on here then. So I will be doing quite some more tests off screen, and then we might flash the BIOS together just to be sure of that. But let me think about this a little bit. So, just to be sure, let's now flash the BIOS on this thing. And what we can see is we have a TPM header right here close to the BIOS. And I want to show you something on the board view. So, if we probe the pins of the chip we can see that they are connected to this TPM header. So this chip select, for example, is connected via this 10k ohm resistor to here. And then the data in is connected via, is it connected? No, this is not connected via this, interestingly. Or for example, this one is connected probably here and again right there. Interesting. So I usually flash the SPIs through this TPM header, but it might not be possible for this one because some of the pins here are actually not connected to the TPM header like I expected them to be. So yeah, using my method probably won't work here, and I will probably have to desolder it. I will try it first with my cable, but I don't think that we're going to have any luck on this one with it. So as expected, the onboard flashing didn't work. So what I got is this neat little breakout board that takes it and um, breaks it out to this pin header, the usual one that we know. And this has multiple different footprints that you can use. Let me show that in the overview. And as you can see, this is the board where I've managed to solder it on quite easily, and it just breaks out to these pins right here. I've ordered this after struggling so much the last time soldering one of these QSON WSON8 chips with the ground plane. And yeah, now this was pretty easy, and now it will be easier to flash. And now in the programmer, we can just read the identification, and it just takes the correct chip that we need. And now let's read the memory to buffer. And now our contents has been read. Let's just delete this now, erase the memory. I'm not going to back this one up because this is already one that someone has put into here. And now the chip is clean. So what I will be doing now, I will be getting the newest BIOS from the MSI website, and we will be flashing it onto here. So this is the new contents, and let's now write buffer to memory. So now the BIOS has successfully been flashed, and let's see if that brought any difference. So I haven't tried this now. The chip is now back on the board. Let's put everything together. I gotta be honest, I don't really expect this to change anything because it's very rarely a BIOS issue when you have no reaction to the power button. But let's see. I just want to make sure because we don't know what has been put onto here, what kind of BIOS. So let's see. Passive power consumption looks the same, and still no reaction to the power button. Okay, just like I thought it would happen. But very good. But it's good to know that the BIOS is correct that you have on here. So, while going around the schematic of the board, I actually found out that this windbond chip here in the bottom is a ROM chip for the SIO, which sadly is really bad for us because we have no way of confirming this. Which means that this could be one of our potential problems actually, because we won't be able to verify the firmware that's on the SIO, and the SIO is responsible for our startup sequence, which we have a problem currently at. It doesn't look like it has been flashed or soldered or anyone tried anything like it. Well, they also wouldn't be able to because there's no firmware to put onto there because it's not openly available. So I will keep that in mind because this could be a potential problem. So I was banging my head onto a wall for quite some time to try to figure out what is wrong with this board. And then I've stumbled upon this here. This is the lower part of the VRM. This is how it's supposed to look like. And look at that. Like, Someone has been trying to solder here and definitely didn't get enough temperature into this. Like, this board needs a lot of temperature. When I was changing out, when I was desoldering the BIOS chip, it took quite some heat for it to actually desolder. Took quite some time. And seeing this, someone definitely didn't have enough temperature in this board to solder it properly. So what we can see here is there's one capacitor right here that isn't soldered properly. There's this 2.2 ohm resistor that probably isn't a 2.2 ohm resistor anymore. And then we have this resistor right here. So let's first have a look at the board view, what these are supposed to be. So now in the board view, let's see, this is supposed to be a capacitor. Okay, and this is supposed to be the 2.2 ohm resistor. If you can see, 2.2 ohm right here. And this is a 1000 picofarad capacitor. And what are they responsible for? They have some sort of signal line that is carried here. Cannot really tell you where this goes. Okay, and the capacitor that we've seen is this one. This is a filtering cap. So this isn't too important, but this might be really bad for it that this was blown up. So let's get rid of the components that are there and replace them with good ones. So before getting rid of all of them, I just want to see if that resistor is still a 2.2 ohm resistor or not. Because we might be able to just solder it properly. It's a little bit high with 3.6. Why is it not? It's not displaying for you. Why is it not displaying? So let's see again. When we go on here, now you can see it. It's 3.7, which I don't like as a reading. I'm just going to replace it just like that capacitor and that one were right here. So let's do that now. Let's get Flux onto here. Like, these were basically not soldered. These were basically laying on the board. So let's get some leaded solder onto all of these pads. Now there you have proper solder on them. And now I will need to find some donor parts. So I've partially placed our components here. And now we're going to actually solder them in place. So I'm not 100% sure if that capacitor actually settled to that part over there. So let's quickly see if that is connected to ground. Just probing the top of it. Yeah, it is connected. Okay, so we've now replaced these two components. And I don't need to place that capacitor necessarily, because that is a V-core filtering cap. So that is not really important. So for now, we're going to leave that one out, because it will not be mission critical. So let's now see if we have any change right here. Let's connect this up. And let's hit the power button. And we still have no change. Whew. Quite sad. Still nothing here. Oh, well, back to the drawing board. So I've spent quite some more time, and I was looking at this diagram and the schematic. This is of the U9, which in our case is our NCT 6687D, which is our Super IO, and it has different like a structure. Like you see, the 32K 7.68, this is just the crystal coming in. It has some power pins. It has ACPI function, which is our interesting part. Fan control, KBC function, SMB bus, LED control, UART, hardware monitor, GPIO, port, LED control, printer mode, SPI ROM, and LPC interface. And we are interested in the ACPI function. Really don't know what this stands for, to be honest, but what we are interested are all of these. RSM, RST, PS in, PS out, sleep state 3, sleep state 5, PS on, ATX power good, power OK 1, and reset. And also the other resets and power OKs. But mostly like the furthest, these top ones, these are the most important for us. And we know, I've looked at, we have PS in and PS out. And I was looking at RSM RST, which is pin 101 in the board view on the NCT. And let's look at that. So this is our pin 101. This is RSM RST, as you can see in the top, and it connects to multiple places. One place is this 22k ohm resistor that on the other side just has 1.8 volts on it. This is just a capacitor that goes to ground. Then we have this, I don't know if this is a MOSFET, I think, or a transistor. And piano, I think this is a transistor, and that has has a signal that is called quite closely to it, like RSM RSTD, that is connected to this resistor right here, which is a 47k ohm, which has 5 VSB on one side and RSM RST on the other one. And I noticed that on this side we have the 5 volts, and on this side we have 0. So this is probably pulled to ground by something. And as you can see here, this is responsible for quite some other power grid signals and similar stuff. But let's go back to the original RSM RST signal. And I've noticed that this is 0 volts. And let's see what happens when I inject voltage at this point here, which is the RSM RST. So I've currently 1.8 volts on this on these tweezers right now with my power supply, and have a special look at what the power consumption does, and also the boot LEDs. And what we can also do is, let's connect this up onto here. So I'm going in right now. I have bad contact. Let me try that again. And have a look at that. Do you see that? 3 amps. Oh, I slipped again. And look at that. 3 amps. And it's going. The post codes are going. The post LEDs. We have VGA. And there's a post screen. Can you imagine that? It is posting. But I have no idea where that signal is supposed to come from. So we are missing RST, RSM for it to turn on, because everything else seems to be working. And I want to show you what I can see on the schematic for that. So let's follow the RSM RST that is supposed to be an output, as you can see by these arrows here. So we're going to copy this and we're going to paste it in and going to search for it. And let's see. Which is our first result? Our first result is here, RSM RST, coming from the SIF socket. So this is a connection from the CPU. So this connects, it goes into the CPU. So this is a reset signal for the CPU itself. So let's look at the second one. The second one is that one at the bottom here. This is the 22k resistor that we've seen, where we have connected. This is the 22k ohm resistor that you see where I was putting in voltage. And one of the things we might want to check if this is still 22k ohms, but I cannot imagine that this is not 22k ohms. And there's 1.8 volts at the other side. So let's go further. The next is actually the actual SIO. As you can see twice here, where these signals should be in output. And then we have this here. And now we can see that we have an outcoming signal here, RSM RST, resulting from 5 VSB with RSM RSTD and S5 power good, controlled by a gate that is VDDP VSB power good. And what I want to look at right now is if we have VDDP VSB power good and if we have S5 power good. So these are the two I want to check now. So let's now check the RMS RSTD that is currently marked. So write this here. So let's go into voltage mode and let's check that, which is supposed to be this one. And we have nothing. Just checking. Oh, wait, my ground's... Okay, once more, because my ground prompt wasn't there. And we have nothing. When pushing the power button, also nothing. So we have nothing on any of these. So let's now look at VDD VSB power good, which is the gate. So it's supposed to be the pad right here. So this is 5 volts. So this gate is connected. So we do have this here, which means these 2 points should be connected to each other. And let's now see what S5PG is. And this is supposed to be this right here at the bottom, this test point. And this has 0 as well. So this is 0. And our RSM RSTD is 0. The only thing that we actually have is the gate voltage that is there. And we have the 5 VSB here. And the question is, why don't we have voltage here? Like, is this resistor dead or not? Let's see. This is supposed to be a 22k ohm resistor. So let's check that. It shows a little bit higher. It shows 47.35. It might be because it's in circuit actually showing this high. But this is the only lead that I have right now. So what we're going to do is we're going to move this one a little bit to the side so we can check it out of circuit without completely desoldering it. So we're going to do is we apply solder to flux first to it. Then we apply solder to both of its sides. So solder is on there. And let's now, what I do is I use hot air. And I just move it one pad to the side. And I've lost it. And I was very lucky. I was actually able to find it. The battery caught it. So the battery holder caught the resistor for me. Well, I would have had a replacement nevertheless, but I really wanted to check if this one was bad or not. And now, with one side desoldered, it is out of circuit. And we should be able to test it now. So let's see. And it is 47k, while it is supposed to be 22k. Interesting. This resistor might be actually bad. So let's completely get rid of it and put a... Never mind, I just looked at my schematic. I'm confusing that resistor with a different one. I was confusing this one with the 22k ohm where we were inputting voltage. This 47k ohm is actually right. Well, I just double checked at the schematic. So it is supposed to be 47k, so this one is spot on. Don't mind me waffling about it being wrong. So right now I'm quite at a loss. Really don't know how this is supposed to work. So if we look again here, we have the 5 VSB here. We do have... This resistor is good, but we don't have voltage here. We do have voltage on this gate, and we do not have S5 power good. So let's see where S5 power good is supposed to be coming from. So the interesting thing is the S5 power good is only connected to itself, and the next pin to it, as you can see, it only has 2 connections. So let's see on the schematic. Here you can see it quite well, S5PG and S5PG right here. So these are connected to each other. So it would be more interesting to know if we have CPU 1.8 S5 power good, if this is present or not. So let's check that. So let's see at this pad right here. I think it's supposed to be 3.6 volts, 3.5. I have bad connection to here. 3.6 volts. So the power good signal here is present. So we have this power good signal, even though it's a little bit weird how it's 3.6 volts. Let's see where this is coming from, because if this is present, then there's basically nothing left but that this transistor might have failed. So I, with my small brain, can't quite put this together, how this is supposed to work. So let me go through this one by one. We have CPU 1.8 S5 power good, which means this gate is pulled high. And if this gate is pulled high, then source and drain are connected to each other, which means S5 is being pulled low. And not only S5 is being pulled low, because we have VDDP VSB power good. This is also, this gate is powered and source and drain is connected, which connects RSM RSD to ground, if I'm not mistaken. So the question is this supposed to be not present? This is my question now. If this is supposed to be not if this is not present, then this is closed. S5 is not connected with ground, which means RSM RSTD is not connected to ground. And because VDDP VSB power good is still there, S5 should go high, just like RSM RSTD, because of the 5 volts VSB that is here. Because currently these 5 volts VSB are being pulled low, if I'm not mistaken, by this gate being enabled and this gate here being enabled, and it being pulled to S1 as being S5 being pulled down to ground here. So we would need to like get this signal off of there, like cut a trace or something like that to this from this power good signal, to see if then our RSM RSTD is present or not. But my question is, if RSM RSTD is present, then do we have, because this is the same transistor, and if this gate is powered, then we have a connection from drain to source, which pulls RSM RST low, which we don't want, because we want to have voltage on here. So I really don't know what is supposed to be happening here, or if this is actually right how this one works right now. Because this might be right, because if we have voltage here, like I said, then drain and source are going to be connected, and from drain to source then there can be current passing into here, which would pull this low. But this means that we would have to search for RSM, RST somewhere else, which is only the only the SIO itself. And yeah, and we don't have voltage coming from the SIO. So it's probably still a problem why the SIO isn't putting out the RSM RST signal. And one of the only things I know now is that we do not know if the BIOS that is on here, which is this SPI ROM right here, if this is correct or not, if this has the right thing on it, the right BIOS, the right firmware. Because otherwise I'm really not sure what is preventing the SIO from giving out RSM RST. So this is sadly the furthest I can go with this, because I just don't know why that signal is still low, why that signal is not being pulled high by the SIO. I just cannot figure it out. We've proven that this board can work. With all of the work that has been done to this, all of what has happened to this board, we still got this to boot up and go into BIOS just by inserting a single voltage. Like, only putting RSM, RST there is like really nothing special, but I just cannot for the life of me figure out why that SIO isn't giving that voltage out. Maybe someone in the comments who's a lot more experienced and smarter than me can tell me what is absolutely necessary for RSM, RST to being put out by the SIO, but I just cannot figure out. Like, the MOSFET circuit that we looked at, I think that isn't our problem, because that would have just pulled it low. So I'm really not sure what is our problem right here with this board, but I'm happy that I went so far and could pinpoint the exact voltage that we're missing, but I really would love to fix this properly and make it work like a normal board. And yeah, even though this board has so much damage and has so many little points where I would say, like, what did the previous person do? Like, we would still have to fix all of these capacitors because they just look awful the way that they've been sorted. But yeah, maybe someone of you can tell me what to do, what to look out for here. But I hope you learned something. I hope you enjoyed the video. All of my tools are linked in the video description as always. Thank you so much for watching. Hopefully you subscribe and we can see each other in the next video. Thank you very much and goodbye.